This presentation provides an overview of Chapter 11 in the book titled Simple G, a gridded economic approach to analysis of sustainability of the Earth's land and water resources, edited by Aman Hakiki and Thomas Hurdle, and published by Springer. This chapter introduces you to the gridded version of Simple G, and delivers a deeper understanding of the results than you would receive by simply viewing maps of model outputs. This slide provides an overview of all chapters in the Simple G book, each of which has an accompanying presentation to motivate the material covered in that chapter. During this presentation, I'll cover Chapter 11, which is on gridded implications of total factor productivity growth. Previous chapters laid the groundwork by providing theoretical foundations, introducing general conditions, specifying mathematical equations, discussing the gridded data and parameters, computer implementation, and validation. Chapter 11 offers an introduction into the gridded model and the interpretation of results, and follows naturally upon Chapter 10, which we recommend you reading before embarking on this chapter. The challenge with gridded modeling is how do you develop a rigorous analysis when tens of thousands of grid cells are in play? The approach we'll use takes advantage of the hinge separating our global simple model from the gridded US component. This chapter introduces novel techniques for undertaking gridded analysis within the Simple G framework. Using Simple G, we'll explore the impacts of a marginal perturbation in US total factor productivity, or TFP growth. We'll demonstrate the model results, mirroring the results obtained by using the theoretical equations from Chapter 3 in the Simple G book. Then, we'll run the global TFP shock scenario and show that the equivalent gridded results can be obtained from a mini-model, which takes as its input the US crop price change, along with grid-level changes. In this case, TFP. Simple G1 is based on two aggregated inputs: natural resources, a category that includes land and water inputs, and human resources, which includes all manufactured inputs and human labor. This allows us to leverage the foundational economic theory of Simple G to understand the model results. The Simple G1 model was developed to serve as a bridge between the simple model and the rapidly proliferating versions of Simple G, which involve more complex production functions. In the spirit of Simple G1 has just one constant elasticity of substitution, or CES nest, in its production function, mimicking the simple model in this regard. So what is the mini-model? The Simple G1 mini-model is designed to replicate individual grid-level results of the Simple G1 model by taking only the equilibrium price changes from Simple G1. All grid cells are connected via prices in Simple G, so if you know the prices, you can solve the outcomes in each grid cell individually, which is the logic behind the mini-model. Step 1 involves solving the full model for the relevant policy scenario and obtaining the equilibrium price changes. Step 2 involves using those prices to examine grid cells of special interest individually to understand the difference. In practice, we can embed the focus grid cells or mini-model at the end of the main model so that steps 1 and 2 are done simultaneously. For the mini-model analysis, we selected 12 grids, representing the range of important Simple G1 parameters, namely the land supply elasticity, cost share of land, and the land, non-land input substitution elasticity. Table 11.1 lists the values of these parameters, and the subsequent map shows their location in the US. We observe that in some grid cells, resource supply is largely unresponsive to price, or inelastic, such as grid IO4-106 in the state of Washington, and others are considerably more responsive or elastic to price. In contrast, the supply elasticity of human inputs is more elastic and assigned a uniform value, given the lack of grid-specific estimates of this parameter. we can see that the elasticity of substitution value varies greatly across grid cells, implying that in some grid cells, the potential for boosting production at the intensive margin, substituting non-land for land inputs, is significant. For example, the elasticity of substitution is greater than 0.6 in states like Nevada and Idaho, but much smaller in other states. A small value suggests that the application of more variable inputs, for instance fertilizer, will not greatly increase yields. In Part 3 of this book, we discussed further details on how this parameter is calculated. The grid cell level share of land rents in total production costs is also quite variable, ranging between 10 and 30%. We begin with a simple 1% perturbation of TFP in the US, and examine how this plays out at the level of individual grid cells, while holding market prices fixed. The goal of this experiment is to explore the local level impacts of the 1% TFP shock, for which you need to complete the results for the 12 focus grids in the US, in Table 11.2. Columns 2 through 4 show the impacts of the 1% TFP shock on input use and crop production. The next 3 columns, 5 through 7, show the same results calculated using the theoretical equations listed on the left-hand side of this slide. The results for simple G1 in the corresponding columns, then calculate the adjacent columns, using the parameters given in Table 11.1, and the corresponding equations. By comparing these two sets of columns in Table 11.2, we show that the simulation model results can be replicated for a marginal perturbation of the model, with our analytical model using the relevant parameter values. For larger, non-marginal changes, the analytical formulae will yield different results, since these formulae are based on a local linearization of the underlying, nonlinear model. Next, we implement a global baseline scenario, not only shocking the supply side, or TFP in the US, and TFP in other world regions, but also the demand side, including population, income, and changes in demand for biofuels during the period of 2017 to 2050. This generates regional and gridded outcomes, allowing us to explore the impacts of demand and supply-side shocks in the rest of the world on individual grid cells across the US. Since the US is a major producer of food consumed across the world, changes in the productivity of the agricultural sector and changes in the demand for food in the rest of the world have a substantial impact on the US agricultural sector. The simple G1 mini-model is designed to replicate individual grid-level results of a simple G1 model by taking only the equilibrium price changes from simple G1. This shocks the crop price and regional TFP in the United States, and includes the subtotals that give us context for what is driving these results. This is possible since the price changes carry all the relevant market information determined by the global model. The simple G1 mini-model can be run on a few selected grids, for example, the 12 grids previously discussed, provided you already have the market price changes. These grid cells are typically selected due to their perhaps surprising outcomes, as well as potential relevance to local policymakers. Of course, any local policy or technology changes must also be communicated to the gridded model. So in the case of this simple G1 experiment, each grid cell will be shocked, both by the crop price, which is deemed exogenous to local producers, as well as TFP improvement experienced by the local producer. In summary, the mini-model is an extremely useful tool for explaining outcomes at specific locations, and can also serve as an aid to debugging a model, as well as identifying problematic parameters. In short, it's an essential tool for those wishing to dig into simple G results. On this slide, you'll find the link to the Simple G web page where you can find additional resources, as well as links to the book and other chapter presentations. Lastly, we also gratefully acknowledge support from the U.S. Department of Energy, the Department of Agriculture, and the National Science Foundation. Thank you for watching this presentation on the Simple G book, Chapter 11. We encourage you to explore the other companion videos that accompany the book on the Simple G web page.